Hello, AP Physics students. Are you nervous about the upcoming exam? Freaking out about the ways that a ball could drop from a ceiling and you don't even know how to measure the speed? Well, don't worry. I have got you covered, all right? So the first thing you got to look at are the kinematics equations. Your best friend in the whole wide world, your equation sheet gives you these three beautiful bad boys. You don't have to commit them to memory because they are right there. But they're not the most useful. A lot of times you got to figure out how far something moves and you only got one of the variables. So I've prepared for you these two additional equations, all right? Anytime you have the formula sheet, I encourage you to pause the video, look at these formulas, and commit them to memory so you can include them on your formula sheet, and they too can be your best friends. The first one we're going to look at is that delta x equals a change in velocity times the time. That's obvious, right? Because velocity is delta x over time. But also, it equals 1/2 times the average of the velocities times time. So if you take the average of the velocities, multiply it by time, that gets you the delta x. So a lot of times you don't even have to worry about multiplying it by the change in velocity if you can add them up at the end. This is useful when you have position time graphs, as well as if they don't give you necessarily an easy way to subtract the numbers. The next thing we're going to look at is if delta x is equal to the final velocity multiplied by time minus 1/2 times the acceleration times time squared. This mirrors the equation we have up here, right? Where it's the initial times time plus 1/2 acceleration times time squared, right? Over here, the only difference is instead of initial velocity, we're at minus final velocity. And instead of plus, we're at minus 1/2 acceleration times time squared. Then now, let's roll it on over to looking at rotational dynamics, all right? If we just memorize these 5 equations, right, all you gotta do is just memorize a few more signs. If you see a fancy looking W, either looking like this or looking like this, it's the omega. And as long as you remember that omega is angular velocity, we're good to go. Next thing you gotta look at is delta x is the same thing as delta theta, or just theta. If you don't see a delta, you're still fine. You just plug in delta x and theta, or just regular x and theta. Finally, with acceleration, we can substitute it with alpha for angular acceleration. And that one's the easiest to remember because A's already kind of look like alphas. Now finally, with our next set of kinematics equations, are going to look at gravitational motion. Delta x is just height, delta y, and our A is g, which is 9.8 meters per second. But if you're in a rush, just use 10. If it's good enough for engineers, it's good enough for you. Finally, let's look at the next big idea. Forces equal forces, right? No acceleration is the same thing as a constant velocity or no motion. And if you see a force equation in your formula sheet or that you remember, you can plug it immediately with another force equation that is working in a parallel direction. Now remember, perpendicular forces do not change the value of the force, only change direction. So if I have 4 newtons going to the right and negative 3 newtons apply downward, my net force is going to be negative 5 going to the bottom right? It is not going to be changed. It's not changing the magnitude of any of these. It is merely changing the direction. Another thing you should remember is that things only move and slow down because of forces. Once we have that basis set, if you see any time in an equation something is slowing down to a stop or speeding up, that is because a force is applied. Once you have that applied, you can really easily quickly go forces equal forces. Now finally, the last concept you have to remember is that energy equals potential energy equals work, right? The sum of kinetic and potential energy equals just individual potential energy equals just kinetic energy equals any energy you have equals work. All of these forms are interchangeable, and if you apply all of these ideas of equality and these ideas of parallel forces and energies, you are sure to ace your AP Physics test.